All right, let's actually read a JSON file into our program. And the simplest way to do this is we have some sort of a buffer. This is a bytes buffer, and we have an error. And we say that we're going to declare those as the result of this built-in package called IOUtil. And what we want is read file, and we pass it a file name, x.json. And that reads in the entire file into this byte buffer. It's not a string, it's a buffer of bytes. And you notice I also declared this error. Now, errors come back as nil, an empty pointer, if there is no error. So if error not equals nil, okay, that means it had an error. Then we want to do something with that error. So we'll do format.printf, and we'll say convert the error to a string and print it out so that we can know what the error was. And we'll just make the program exit if it can't read its file for this case. And this is not the way to write a server, but we'll just do os.exit, and we'll pass it a 1 to indicate that there was an error. So if you get an error on this, it goes boom, it exits, you're done. Now, this kind of a construct you're going to see all over inside Go, where the last parameter coming back from some function call is an error, and the next line down is if error is not equal to nil. Okay? That is ubiquitous, found everywhere in the language. Second thing to note is you'll notice that this returned 2 different parameters. I would have thought when I first started programming in Go that wasn't that big a deal. Today, I look at other languages that can't return multiple parameters, and I go, that's horrible. The ability to return multiple things is just super, super useful all the time. And not having it is bad. Python does it through tuples. Go just says you have input parameters, you have output parameters. The output parameters are, this is how they're done. And you can have as many as you want. You don't have to have 2, you can have 1, you can have 18. 18 is usually excessive, but you never can tell, right? I mean, maybe you need 18. Now, once we have this buffer read in, we'd like to convert it to whatever our data type is. And so we're going to say error, equals, and there is a JSON package, JSON.unmarshal. And the 2 things that we need to pass to unmarshal are the buffer. Conveniently enough, unmarshal takes a byte buffer as its first parameter, and the address of a variable. And I'm going to sneak in here that the variable got declared. We'll sneak it in right here. We'll do a little arrow. You wish you could do this in your code, but you know, whatever our type is. Remember, we had some sort of a type X that's a struct, and we put some stuff in it that matched our JSON file. Well, here we're going to say var, okay, v is of type X. And that's what we passed right here. Var v of type X. Now, one of the things that Go includes is a very extensive ability at runtime to look at the data types of things and actually build code that manipulates stuff via looking at data types. So JSON unmarshal can actually look in, see all the fields, read the stuff in, match stuff up by name in the structures, put it in the appropriate places, build a data type out of this. Okay, now unmarshal, of course, has its corresponding marshal that would take a data type and you pass it a buffer and it gives you back the data in JSON format. There are a couple other parameters to it about how you indent it, but there's a marshal and an unmarshal. Also, Go has the ability to do a set of extended things, so you can have data types in here. You don't have to be just stuck with floats and arrays of structures and strings. If you have dates, if you have special types, if you have complex data, if you have all sorts of data, you can extend the JSON package with other data types that you defined. Now, we got back an error here, and I've actually made something that's going to produce a syntax error. We didn't want a colon right there. We just wanted an equal because we already declared error up here. Go will tell you if you redeclare things, and it will give you an error. You cannot do that. So if you type that in with the colon there, yes, you'd get back a syntax error and you'd have to take out the colon, because you only get to declare it once within any scope. And when it goes out of scope, it is gone. It knows that. Okay. That's also when it has a function. As it goes out of scope of the function, it knows which values have to be passed out. Okay. And you are required to use everything that you declare. You cannot just have dead code in there. So down here we'd have if error is not equal to nil. We do some error processing, and that's how we read in that file. Now, this code is basically in section 1.4 of your homework exercise so that you can go and look at it, copy it, paste it, tweak it, and see what I did in there. Go and play with it and run with it and use it and try it. I think this is the first time I've actually put up ifs, but you'll notice that there is if, an expression, squiggle bracket. There's no extra syntactic sugar parens to make you do extra typing. And again, on line continuation, you notice I broke right after a open paren, and it's indented on the next line. Commas are treated in a weird fashion in Go. I'm just going to tell you. If I wanted to put this on the next line down here, which I could, I would end this with a comma, even though there is no extra parameter. And I would put comma, go to the next line, indent, and put the paren. So if you want to split your stuff out over multiple lines, even if there are no extra parens or extra parameters, you end on a comma, you go to the next line, and this means that anytime you have a list of something, every one of the things in the list has a comma at the end. You don't leave out any commas. And it will complain if you leave out commas. It is not an optional comma. It is a required comma. So there are things that you do like initializers in the language, and you'll go, oh, there's a comma, and the next line's got a squiggle bracket. Yeah, it's a required comma. It's not an optional one. So that's how you read in that file.